Thank you for coming to my presentation today. So today we are going to talk about unidirectional data flow on Android using Kotlin. The main actor, the main topic here is unidirectional data flow. Okay, we are going to talk about architecture, but we are going to also to show snippets in Kotlin because Kotlin. So we are using for this presentation a sample app. The sample app is made in Kotlin, so we are going to show Kotlin snippets that also this programming language, they help us to make our architecture better, okay? So yeah, as he has said, I'm Cesar Valiente. I work at Microsoft in the Nodes team. Those are my social links, so yeah, feel free to ping me and everything. So first, unidirectional. What is unidirectional? It's simple, no? Unidirectional is just one direction, no? So in this diagram, we can see like four circles, no? That A, B, C, D, and if we want to cover all of them, we have different alternatives, no? But I'm going to follow one to see that we go unidirectional and just unidirectional, okay? So for instance, if we want to cover everything, we can go from A to B, B to C, C to D, and D to A. And we are covering all circles, no? So we are not having here loops. We cannot go from A to B and then B to A. We cannot go from A to C directly, no? If we follow that, we have always to follow this direction, and then we are unidirectional. So we always go straight, okay? A little bit before we go through our approach in Android, it's a little bit of history, no? History about unidirectional. Unidirectional is not something new. It's something that has come, that is there like from the 60s, no? It's a simple idea. But recently, like during the last 3-4 years, Facebook has put a lot of effort in these unidirectional architectures, unidirectional approaches in the web world, and with two main approaches, no? Flux and Redux. They are really similar, and we are going to see their components. So Flux and Redux, they have a component that is called the view. The view is the widget, no? It's what the user is going to interact with, no? It's like in a screen or in a web component, no? Will be like a button, for instance. So we click on a button in our an application, we click on a button, or a view pager, we slide the view pager, and so on, okay? I also written like the different logos in Flux and Redux because both they are similar, but they don't share all components, okay? So you see there like the logo of Flux or the logo of Redux is that this approach, they are using these modules. Then we have actions in both approaches. Actions, they are verbs. They are the use cases, okay? If you are coming or you know about clean architecture, that Uncle Bob was saying, action is a use case. So for instance, create an item is an action. Delete an item is an action. Fetch items is an action, okay? We have dispatcher. We have dispatchers in Flux because what we do is like the view, the user is going to interact with the view. We are going to create an action, and then we are going to dispatch this action to the different actors, the next actor that we are going to see right now, using a dispatcher. In Flux, we use a dispatcher. In Redux takes like more functional approach. Actually, they takes the learning from the programming language Elm. So for Redux, the dispatcher is a pure function, okay? And then we have store. Both approaches, Flux and Redux, they have the store that is our domain, okay? The business logic lives there. This is the most important part of our architecture, the store. But Redux also, as I said before, it takes more like the advantage of the functional programming, and it has a component that is called reducer. At the end, the reducer is just a simple function that is going to take an action, is going to take the current state of the app, and then we are going to generate a new state. Really important here is state. These two approaches, they have a state. They have a global state that is immutable. So what we have to do always that we want to check our state is create a new state, okay? We are going to see later like much better how these pieces interact with, and also in the slide that I'm going to upload later, you are going to see like more diagrams regarding Flux and Redux, so everything is clear. But here, because the time, no, I wanted just to show you like the main things, and then we proceed with the rest of the presentation. So one thing that you can think about is like, OK, this guy is coming from Microsoft, but they are doing Android, they are doing Kotlin or something. Yes, we do. So I'm part of the OneNote team, and in our team, we are doing a set of apps in all platforms, web, iOS, Android, and Windows. And we are not sharing code. We are not using Xamarin. We are not using React Native. We wanted to take advantage of our knowledge. So for instance, I've been working in Android since 2009, 2010. And the iOS guy also was doing Objective-C, then later Swift. So we wanted to take advantage of our knowledge. But we wanted to have like a shared approach, like a shared architecture between all of our platforms, OK? Because how many times, guys, you have, I don't know, you are doing an app, you are creating an app, you work in Android, you work in iOS, and then you have a problem. And then you ask to your colleague that is working in another platform, and hey, how did you fix this problem? And then he starts telling you some weird story that for you makes no sense because you are taking another completely different approach, OK? So we wanted to share that. We wanted to avoid that. We are not sharing code, but we wanted to share ideas, OK? So that's the reason that we follow the same approach. Also, it was important that the web team, they were the first one that they started the apps that we are doing, and they are using React and Redux. So then the rest of the apps, Android and iOS and Windows, then we took like the same approach, but in our platforms, with the good things, with the bad things, that we will talk about that later. So that's the reason. For this presentation, and because also I cannot share, at least now, the code that we are doing internally at Microsoft, I create a sample app that it takes more or less like the same, or more or less, no, it takes like the basic stuff that we do, all the learnings that we have done, that we have learned, all the things that we have learned during the construction of the architecture, OK? So I create this sample app, OK, Unidirectional. It's a super simple app. It's an item list app that it has just 2 screens. It's open source, so it's there in GitHub. You can use, you can read it. I wrote like a lot of documentation, so I think it's a really good material to help to understand this much better, not just with this talk and with this slide, but also if you have a look to the code, I think it's good to learn more, no? As I said, it's a simple item list, 2 screens. We create items, and then we delete items, and yeah, we edit items, that's all. Everything is unidirectional. This is really important. So everything that we can do in the app, every interaction that we do is unidirectional. When we open the app, we are doing something unidirectional. We are going to try to modify the state. We are going to read the content of the state, and then we are going to render our views with the state. When we click in the Add button, we are going to create an action that is like going to the screen B, and then we are going to, we can edit items, and then we can save items, and save items is also another action, and so on, OK? And to make easier, like to understand that, I didn't want like to bother you guys about adding new libraries, like because with this approach, like public subscriber pattern, like even Bash library is really useful, or RxJava, the observer pattern is really useful, but I didn't want to use these libraries because then we are adding like more complexity to our problem, OK? So it's pure Kotlin, that's all. This is like the big picture of our architecture, OK? So we have different components. We took things from Redux. We took things from Flux. And this is what we have done. OK. So I'm going to go through this, the general picture of this, like an example, using an example of create an item, OK? So imagine that in our sample app, we are going to create an item. We have the app here. We click on a button, and we create an item, OK? Imagine that. The first thing that click on a button is the interaction with the view, OK? Then the view is going to talk to an entity that is called ControllerView, and it's going to say, hey, ControllerView, the user wants to create an item, so we have to create an item. Then the ControllerView is going to create the action. It's going to create this verb, this use case, that then is going to be dispatched to our store. The store is subscribe listening for actions, OK? It's just an isolated entity that is just listening for actions, OK? Also, our store, our reducer, has a global app state. In the In this app, for instance, our state, the main thing of our state is the list of items, okay? So our state is just a super simple class with a list of items. We also have like navigation stuff, but we will see later. But this is really important. So we have actions, we have a state. The state is immutable. Given one action, we are going to create a new state with the information of the action, and then we are going to dispatch the new state, so then the views, they can render themselves, okay? So then, the reducer takes the action, creates this action that is called create item with some metadata. Imagine that our state now is empty. The list of items is completely empty. Okay, then we are going to take this action. We are going to then to create this item internally, and then we are going to add this item to the list of items. Then our state now, it has the list of items with one element. Then, once that we have the new state, we are going to give the state to the controller view. But also, right after we have dispatched, we have given the state to the entities that they are listening for states. We are going to dispatch also the actions to what we call side effects. What are side effects? Side effects is a way to enrich your data, to extend the functionality of, your application, to extend the functionality of your application. A side effect can be, for instance, a persistence layer, a database. A side effect can be a sync layer, where you create your request, you are handling responses, and then so on, okay? So right after, this is important, right after we have generated the new state, we send the actions to our side effects. If we have side effects, they are not mandatory, we will see later. We are going to see later like how the threading works, but this is not like sequential, okay? So the action that is dispatched to the side effects is asynchronous. So another thread is working that, no? So now the controller is taking the state, and it's going to take just the information that it needs from this state, and it's going to give it to the associated view. So imagine that we are in the node list screen. In the node list, we just need information regarding the list of items, no? So then now we are going to take, the controller view is just going to take the list items from this state, and it's going to give the list items to the view, and then the view will render itself with this new information, okay? And then side effects also, they can dispatch, they can create new actions, and they can dispatch these actions to the reducer. This is optional, so we can have side effects or not, and also side effects, they can send actions or not. A perfect case for dispatching an action from a side effect, for instance, will be like in the persistence layer. We said, OK, fetch list items. We go to the side effect, go to the database, we fetch the items, and then we create a new action with these new items that they are coming from the database, and we dispatch to the reducer, so then the reducer can generate a new state with this information. Dependencies, or how the dependency work here is really important. How we decouple the different elements of the different modules of our app, so then it's much easier to test, it's much easier to maintain, no? So we have the view that they have just Android dependencies. At the end, the view, they are just activities or fragments, okay? And they have Android framework dependencies. They have the context, they have all the Android components, okay? Then we have all these elements, the controller view, the actions, and the restore with its reducer, that they don't have any Android framework dependency. So they are just pure Kotlin code with your standard library, and also with other libraries that you want to use that they don't require framework dependencies. In the sample app that I create, we are not using any library, so it's just pure Kotlin. We don't have any framework dependency. We don't have context. We don't have anything like that. What is important here for that is like then it makes testing super easy, because we don't have to deal with the context. We don't have to make instrumentation tests. So we are not using context. We are not using any Android framework dependency. So then we can in unit test all the different components in a unit test way, okay? And then side effects. In side effects, we can have side effects that they require Android framework dependencies, or we can have side effects that they don't require Android framework dependencies. A case that we need framework dependencies will be like the database, no? Even if we are using SQLite or Realm, no? They need the context. Then we are attached to the Android framework. But for instance, a sync layer that, I don't know, you are using like HTTP, retrofit or something, that they don't, you don't need like the context, you don't need Android dependencies, then will be a side effect without Android dependencies. Also, it's important here to say that the store and the components inside, like the reducer, the actions, they don't know anything about the outer world. They are completely isolated. So coming from clean architecture, from Uncle Bob, our store is our domain. And the domain, the store, doesn't know anything about the outer world, OK? So it's a completely isolated component, module. So then we could plug our store, so all this without framework dependencies, to, for instance, I don't know, a Kotlin backend app, and it will work, because we are not using any Android dependency, and because it's completely isolated. So the store doesn't know anything about the view, doesn't know anything about side effects, OK? Now we are going to go item by component by component, even though we already have said things about them, but just to make it clear, OK? So as I said before, build their activities of Flatmesh. It's just that's all, OK? They use the ControllerView to communicate, to start what the user want to do, what the user want to achieve. No? Like, for instance, create an item. Once that the ControllerView has the information from the state, then it's going to give this information to the view, and then the view will render itself. The ControllerView, if you are used to MVP, at the end the ControllerView is the presenter, OK? So it's just another name that we gave it because we were using Flux, and in Flux they have also like a component that is called ControllerView that does basically the same, so then we stick to the same name. But if you are coming from MVP and you are used to Model View Presenter, ControllerView is a presenter, OK? So it's the man in the middle between the UI and everything else, no? It's like the way that we can decouple framework with, from our business logic, from our domain. Usually that, no, one activity, one Flatmesh, one ControllerView. This is up to you also. The ControllerView creates the actions, and then it's going to dispatch the action. It's going to invoke a function, a pure function from the store, and then the store is going to realize that there is an action, and then will do its stuff, no? And then, as you can remember from the previous picture, like with the whole flow, the ControllerView receives a new state, and then it's going to handle this state, and will take the information that it needs from this state to give to the view, and then the view will render itself. No? In a web world, the view will be like the React stuff. Okay, it's like given a state, it's going to render itself. So, for instance, a super simple app, how like a base ControllerView looks is that, no? We are injecting everything like manually. As I said before, we are not using any dependency injection framework to make more complex this stuff, and it's just two dependencies, no? So we have the store, we have a thread that with this thread we are going to say that, okay, once that we have the information from the state, then is where the ControllerView is going to invoke the view, no? The view can render itself. But also, this is really useful for unit testing purposes, OK? So then we can give a null thread, in our case, or another thread, and then our unit test can run synchronously, like, without dealing with any threading mechanism or any threading issue, no? And the store is like the main dependency, is what the user, the ControllerView, then is going to invoke to dispatch actions. So this is the super simple function. Given an action, we are going to dispatch, we are going to give to the store this action, and then the store is going to do something. Remember that I said before that in Flux, it's a completely different component, but in Redux, it's just a pure function. And then we are following the same approach, because also Kotlin helps us to do like more functional programming, no? And then just a handle state that, given a state, then we will do something with that, no? So as I said before, this is just a base ControllerView. Every ControllerView then is going to override this function, and then it's going to do their own stuff, okay? The action, as I said before, is an intention. It's what we want to do, what we want to achieve, no? Create an item, delete item, fetch items, mark an item as favorite. Yeah, actions, use cases. They can have metadata, or, for instance, create an item. We require, for instance, in our sample app, that it has a text and it has a color, no? And if it's marked as favorite or not. But also, it can be an action without any metadata, like, for instance, fetch items. Fetch items, we don't need metadata. It's just an intention. No? It's like, oh, give me all items from the state. Actions, they will be reduced or handled. This is kind of the same, but I wanted to make like the distinction because the reducer is going to reduce actions with the help of the current state. But the side effects, they are going also to handle actions, but they don't have access to the state. They are not going to reduce any state. They are just going to take an action, they are going to do something with the action, and eventually or not, they will dispatch another action. So just to make also clearer, no, I like rename it these two ways to handle actions. Actions, for instance. In Kotlin, we are going to take advantage of the language, no? And we have seal classes. Seal classes, they are really useful to like group all like the classes regarding their purpose. So then later, when we are going to go through all of them in our reducer, it's easy to cover all the different cases, and with the help of the compiler, if we forget to cover a case that is covered by a seal class, then the compiler is going to give us like an error, no? When we are typing. But we are going to see this later, like better, no? So we have a main seal class action, no? And then we have different seal classes regarding update action, reduction, create action. And inside of this, every action, we have data classes, no? That also we can take advantage of Kotlin, and we have here like complete classes with getters and setters, with toString, hashcode, and so on. But also, it's really important, they are immutable, okay? And we are going to take advantage in this architecture, this approach about immutability. The state is immutable. The actions are immutable. We cannot change the content of an action. We cannot change the content of an state. So then, everything that, when we take advantage of immutability, then our code is going to be safer, okay? Yeah, so simple actions, reorder, update. With red, it's the same. We have also action for create and for delete, okay? The store, this is our domain. This is where our business logic lives, okay? It has the state of the app. As I said before, the state of the app is an immutable object, and it cannot be changed. But we can create new states. The store will handle actions, and they will reduce an action and generate a new state, no? And will dispatch the state to those state handlers that they are interested to handle state. In our case, these state handlers, they are the controller views, no? As we have seen before, the controller views, they wanted to handle different states. Yeah. After we have generated a new state, then we are going to dispatch the action to the side effect. This is a sample of our state, our immutable state, okay? Here is like, so the state has to have what we want to, so the information that we need from our app, okay? In this super basic app, we just need the list of items, okay? But also because we go like fully unidirectional, we also have like the current position of our application, no? So when we are in the activity A, then for instance, we are in this item list. We are in the activity B when we go to edit an item, when we are in edit item. All these sub-states, no? Item list screen, edit item screen, they are also data classes. They are immutable classes, okay? So we cannot change that. And then at the end, we have our state. Our state is composed for these sub-states, and also is an immutable class. How the store looks. The store is also super simple. We have a list of side effects that they are, like as I said before, it can be the persistent layer, it can be the sync layer, or it can be nothing. If you don't want a side effect, it's fine. Then you have state handlers that in our case, they are the controller views, and they are these actors that they are going to handle state, okay? And then the thread. As before, we can say where our store is going to run. And also for unit testing purposes, this is fine. This is actually really good, because if we don't give any thread, then the store is going to run in the main thread, in the thread that has been invoked, okay? Here we see a super easy. So this is the function that is going to be invoked when we have a new action. As you see here, is like reduce. We have an action, we have the current state, and then we are going to generate a new state. We dispatch the new state to the state handlers, and then after that, we dispatch also the action to our side effects. The function that is used to dispatch new states is easy. No? It's like, OK, we have the new state, so then what we have to do is this new state is going to be now our current state, the first line. And then our state handlers, they are going to be invoked, no? Like, hey, you have this state, so you should render yourself. But as I said before, the store doesn't know anything about state handlers or side effects. Side effects and state handlers, they are going to subscribe to the store, but the store doesn't know anything about them. This is like a pure reduce function, no? Here we are like following like divide and conquer, no? At the end. So we have a main reduce action, given an action, current state, we generate a new state. But here, this is the cool thing of the seal classes. With we are using a when case, and given the action, we are going to cover all different cases that they were covered by seal classes from Kotlin. All of them, they are seal classes. If we forget to write one, imagine that if we forget to write creation action to cover this case, then the IDE is going to tell us, hey, you forgot that, so you should add this case. No? So seal classes, they are really useful for that, no? For our reducers. And then, as you see here, every creation, every associated group of actions, they have also their own small reducer, OK? So then we follow like divide and conquer, and then it's easier to maintain, it's easier to like handle the different groups of actions and reducers and so on. Once that we have a new state, then we will return the state, and then our views, our controller views, they will handle the state. Again, reduce an action, create a new state, reduce every part of the state independently. We are going to see now, and the result new state will be dispatched. In a more graphical way, we have our store. In the store, it leaves the current state. Imagine that is now the list of items with one item. We create a new item. No? We dispatch an action with a new item. Then the reducer is going to take the action, is going to take the current state, and then it's going to dispatch a new state. As you see here, yeah, it's like the item list. We divide, so the state is immutable, so then we are going to take advantage of immutability in Kotlin and copy the copy function, so we are going to reduce just the different parts that we need to reduce. If we are, for instance, in our action doesn't have anything regarding item list screen, then we are going to take the content from the previous state. So then we don't have to change always all the different parts of the state. Models, they are important. I'm going to be now a little bit faster. So we have store models. We have presentation models. We don't have presentation model. They are the same store model plus some extension function from Kotlin, OK? Because at the end, we don't need, in our sample app, we don't need presentation models. They are the same. And then the persistence, yes, the persistence, we have persistence models with some mappers, no? OK, the store model is simple. It's also, again, immutable classes, easy. We have local ID, text, favorite, and so on. Then this is, I wanted to write this because sometimes the people doesn't know, this is super simple. But in Java, for instance, we have like, when you are using, for instance, two classes with the same name in the same class or in the same class, then you need always one of them to use the whole package name, no? So in Kotlin, we can use aliases. So then at the end, we can rename these classes with new names. Mappers, using extension functions in Kotlin, they are super cool, no? Because we don't need like static functions in Java, no? We can create like every item knows how to transform itself, no? In this case, for instance, from a store item, we go to a persistent item. Presentation models, as I said before, we don't have presentation models. We have the same store models, but we enrich this model using also extension function. So imagine, so in our case, our items, they have colors. They have an enum that is red, yellow, green, blah, blah. But our presentation layer doesn't know anything about this, what it means, this enum, no? So, and we don't want to create new presentation model just for that. So we can take advantage of the extension functions and then mapping like the enum, this enum that is from the store, is this value in the presentation layer, no? And also we avoid, if we do this here, we avoid that our store, it has Android framework dependencies, because the resource, the R, lives just in the presentation layer. The same with testable ID. Side effect, as I said before, extend the functionality of the core logic. We can have 0 or as many as we want, and they handle actions after the store has reduced. So the reducers, we can have side effect 1, 2, or n, and then we can send actions if we have actions, and then we can also dispatch different actions to the reducer. Threading is really important here. So our view, of course, is going to run in the main thread, but as you have seen before in all the different snippets, the store also receives a thread, so then the store is going to run in the thread that you wish. In our case, the store is going to run in the store thread, and the persistence, every side effect is going to run also in its own thread, okay? Testing then is easy, because we can have UI tests in the presentation layer, so espresso test, for instance, because it's completely isolated. Unit and integration test in the controller views. In the integration test in the controller view is really useful, because remember that our controller view is going to create an action and is going to handle the new state. So it's the perfect place where, given an action, given the new state, we can test that the state that we have now is the expected state that we should have given this action. Unit and instrumentation test in our persistent layer. In this case, we have Android framework dependencies. Unit test, just pure unit test in our store layer, because we don't have framework dependencies. I wanted to show you like 2 super short demos, like what is happening under the hood, okay? In the interaction with the sample app. So we open the app. The list of items is empty. We are going to create a new item. So we go to the activity B. We type a new item, and it's white. That's all. Easy peasy. Now, so what has happened under the hood is, remember, we open the app, okay? And then we create an action, fetch items, no? Then we are going, so we give the action to the store is going to reduce this action. The state in this case is empty, so then our state is an empty list of items. Then we have clicked in the plus button. Then we have said, okay, this new action, open edit item, I want to go to the activity B, no? And then we have dispatched this. Then our state has been changed, and then our controller view is going to handle this state, and it's going to say, oh, okay, now we have to go to the activity B. In the same interaction, we create this, then we type the text of the item, and then we click back, no? We have clicked back. We want to save the item, and also come back to the activity A. So we have dispatched save item actions. So now our state, it has one item, was empty, and now it has the item that we already have saved. And also, we have said that, okay, we have to go to the node list view. So we update the navigation, our state is also new, and then we render this state. And then the last thing that we have done is like the same that when we open the app was like, okay, fetch list items, and then now our state, it has a list with one item. And now the last demo is like about side effects. How? Because side effects, as I said before, they are optional. So your app should work. I mean, of course, if your app really depends on online mode, you need a sync side effect, okay? But in this case, that our app is super stupid, it's super simple, I wanted to show you how this approach, how this architecture can work without side effects. Because the state lives in the memory. So all items that we are going to have, they live in the memory. This is up to us if we want to persist them, okay? So in this demo, we are going to see how we can work with or without a persistence side effect, a persistence layer, okay? A database. So we open the app, we check that the persistence is enabled. So right now, the side effect of the persistence layer is enabled. We have a database. We create an item, change the color, click back. We are going to create another item. Now, we kill the app. but we have side effect. We have persistence layer. So our items, they are there, OK? Now we are going to disable the persistence layer. We kill the app to make this chain active. I could have done this without killing the app, but I was kind of lazy in that day. So now we don't have anything. We don't have side effect. We don't have an actor that is subscribed to our store. So our persistence layer is not listening for actions. So we don't have any database. And the store doesn't know anything about side effects. It's just this, if it's someone listening for action, it's fine. If not, so then we create items. Our items lives in the state, but the state is in memory. But we are not persisting anything because, again, we don't have persistence. Now we are going to kill the app. So our items, they were living in the state, in memory state, there is nothing. Now we are going to enable the persistence. We are going to kill the app. And then our original items, they should be there, no? Because now we have a side effect. So now the action, this fetch list item action, the store has reduced that, and also has given the action to the side effect. And then the side effect, the persistent side effect has said, oh, OK, this is the action. Then I'm going to go to the database, query the items, and I give you to the items, OK? And the last thing, some thoughts about this approach, this architecture. This is not the philosopher's stone of the architectures, OK? We have clean architecture, we have onion architecture, hexagonal architecture, your architecture, no architecture. So different, this is not like the you should follow or like you should stick to this. It's another option, OK? But that is a fact that unidirectional makes your code really easy to follow, because as you have seen in the whole process, we are just following one direction, and we have just like concrete places, that we do stuff. So makes our code really easy to follow. It's really important. Decoupling elements makes your app, the maintainability of your app and testing easier. As we have seen before, every component has been can be completely tested in an isolated way. Immutability makes your code safer. As we have seen before, we cannot change the state. But we cannot change the state just in the reducer. We are generating a new state. But what is more important is that if we are working, for instance, in a team or something like that, and another person tries to modify the state in the presentation layer or something, you cannot change that because it's an immutable object. The same with actions. And the same with, I think immutability makes, like, in general, your code safer. Take advantage of the tools you have. With this, I wanted to say, like, if you are using Kotlin, try to take advantage of the programming language, OK, of immutability, of shield classes, or functions, or all these super cool functions that all the list has. In the future, eventually, core routines, when they are stable. So take advantage of that. And as a final point, what is good for our problem has worked perfect. We have the same architecture, the same approach. I can go to the Swift code, and even if I'm not a master of Swift, I know all the stuff because, OK, it's the same components. They have the reducer, they have actions, they have the store, it's fine. They have the side effects. If I go to web that we do TypeScript, it's exactly the same. We have the store, the reducer. At the end, some changes, the little changes that we have in the different platforms, they are just implementation details, OK? That's all. I don't know if we have time for questions. Probably no.
No. All questions near the stages. So thank you, Cesar.